Let us discuss a few properties of Hermitian and skew Hermitian matrices. Recall that a matrix A is said to be Hermitian if it satisfies the property A conjugate transpose equals to A. It can also be written as Aij equals Aji conjugate because Aij transpose is Aji and Aij is generally an element in the matrix A. For all ij, that is for all elements, if aij equals aji conjugate, then also we can say that corresponding matrix A is Hermitian. Similarly, a matrix A is said to be skew Hermitian if aij equals minus of aji conjugate, which is satisfied for every entry aij in the square matrix A. Now, if A is a Hermitian matrix, is it always possible that K times A is also Hermitian? When we evaluate K times A, the whole conjugate transpose, we have K conjugate into A conjugate transpose because K is a scalar quantity and transpose is not applicable for a scalar. So, only the conjugate operation works on K. So K conjugate can be taken outside and A conjugate transpose is obtained. Since we have assumed that A is a Hermitian matrix, we have A conjugate transpose replaced by A. Thus we have K conjugate into A conjugate transpose equals K conjugate times A. If K is a real number, then we have Ka whole conjugate transpose equals K times A. So only when K is a real number, we have K times A is a Hermitian matrix. If K happens to be a purely imaginary quantity, suppose we take I, then we have IA, the whole conjugate transpose equals I conjugate into A conjugate transpose, which can be written as minus of I into A, because A conjugate transpose can be replaced by A from the definition of Hermitian matrix, since we have assumed A as a Hermitian matrix, and the conjugate of I is minus I. Thus we obtained I times A, the whole conjugate transpose equals minus of IA. So this is the property of skew Hermitian matrix. So we can conclude that if we take K times A for a Hermitian matrix A, and if K happens to be a purely imaginary value, then I times A or K times A, where K is a purely imaginary quantity, will be a skew Hermitian matrix.